Hey, what's up, everyone? This is a brief overview of the 1.5 angle pair relationships. So remember, intercepting lines are two lines that meet at exactly one point. Parallel lines are two lines that never intersect. Algebraically, they have the same slope but different y-intercept. Perpendicular lines, in geometry, they're pretty much always going to look like a capital T, whether it's upside down or right side up. Algebraically, they have opposite reciprocal slopes, and they intersect at one point. So we've already looked at angles like this, but we're just putting names to it. So adjacent angles are two angles that share a common vertex inside. So if you look at this diagram here, so this point Q is the common vertex, and ray RQ is the common side. So similarly to last section, we have that angle PQR plus angle RQS equals the whole thing, angle PQS. So this is the same thing as the angle addition postulate from last section. We're just putting a name to these angles. These are adjacent angles, which, adjacent just means side by side or next to. So these two angles are right next to each other. They share a common vertex and that common side. We also have some special names for angles that have a certain sum. So complementary angles are two angles with measures that have a sum of 90 degrees, for example, here. So again, this little box here indicates that this is 90 degrees. So we can say angle ABC plus angle CBD equals 90 degrees, which is also angle ABD. Next, we have supplementary angles. Supplementary angles are two angles that measures that have a sum of 180 degrees. So notice that ray CB bisects this line AD, and AD is a straight line, which means that it measures 180 degrees. So similarly, we could say angle ABC plus angle CBD equals 180 degrees. This is also angle ABD. Okay, so these are the only names we really give for special sums. So an easy way to remember it, teacher once told me, is because basically we only have special names for 90 and 180. So 90 degrees is the smaller between those two, and it is a complement to say someone has a smaller waist size. So that might help you to remember which is which. So complementary is the smaller one, so it's 90 degrees. So example 1 just says, find the measure of the complement of supplement of angle 1, given that angle 1 is 22 degrees. So for complementary, you're going to need your other angle to add the 22 to give you 90. So algebraically, you can just say 90 minus 22. So 90 minus 22 is 68 degrees. Similarly for supplementary, just 180 minus 22, which is going to give you 158 degrees. So look at example 2. Angle A and angle B are complementary. Measure angle A, 7x plus 21, and measure angle B is 9x plus 5. I want you to find the measure of each angle. So again, if they're complementary, they add to be 90. So you can just say 7x plus 21 plus 9x plus 5 equals 90 degrees. Combine your like terms, so 16x plus 26 equals 90 degrees. Move your 26 over, and you get 64. Divide by 16, and you get that x equals 4. And again, it wants you to find the measure of the angles. So just plugging in, measure angle A is going to be 7 times 4 plus 21. So if you do that, you end up with, it's a little sloppy there, 21. So if you do that, you end up with 49 degrees. Now for measure angle B, you can again just plug x in to be 4, or since you know they're complementary, just subtract 49 from 90. So 90 minus 49, oh sorry, not measure angle A, measure angle B, you get 41 degrees. 90 minus 49, or again, just plugging in x to be 4. Okay, let's go on to the next. So for the next part, we have another special name. We have a linear pair. It's a pair of angles, okay? So there's a pair of angles with common sides that are opposite rays. The angles in a linear pair are supplementary angles. So a linear pair is basically just letting you know that you have supplementary angles that lie on the same line. Because to be a supplementary angle, the angles don't per se have to be on the same line. In all of our examples on the previous section, they were. But technically, any two angles, even if they are not on the same plane, not on the same line, things of that nature, but if they add to 180, we still call them supplementary. So a linear pair is just specifying that, hey, these are supplementary angles, and they also are just going to be on the same line, as you see in these pictures here. So let's go to an example. It says angle FGH and HGI form a linear pair. Find the measure of the angles if the measure angle FGH is 12x plus 13, and measure angle HGI is 4x minus 9. So again, they're a linear pair, so they're supplementary. So add them together, and it equals 180. Combine your like terms. Subtract your 4. Divide your 16 over. And once you divide your 16 over, you get 11. So now, to get the measure of the angles, just plug x in. Okay, so when you simplify that here, you end up with 145 degrees. So again, for the other angle, HGI, you can just plug x in or just subtract 180 or subtract 145 from 180. So if you do that, you end up with 35 degrees. So next, another special relationship, vertical angles are two non-adjacent angles formed by two intersecting lines. So for example, on this diagram here, 1 and 3 are vertical angles, and 4 and 2 are vertical angles. angles, and vertical angles are always congruent. Later on, we can probably do a proof of this. So in example 4, it says line AB and CD intersect at point E. Find the value of x if measure angle AEC minus 5 and measure angle BED is 4x plus 19. So we can also draw a sketch of what it's talking about. So this is line AB. Intersect at point E, and this is line CD. So AEC, this guy here, is 12x minus 5, and BED, this guy here, is 4x plus 19. Now again, these are vertical angles, so they should be congruent, so we can set them equal to each other and solve. So get all of your x's on one side, so you end up with 8x, get all your numbers on the other side, 24, so x equals 3. And then, similar to like we've done in the past, you can just plug x in to get your angles. Let's look at example 5. So it says identify the angle relationship and solve for x. So these two are vertical angles. They're non-adjacent. So we can set them equal to each other and solve. So we're going to have to factor two numbers that multiply to be negative 24, that add to be 2. We should look at 6 and 4. The sum is positive, so that means our bigger number should be positive. So this goes to x plus 6 times x minus 4 equals 0. Solve for x, so we get x equals negative 6 and positive 4. Now typically we've always just taken the positive number, but note here that if you plug in negative 6 into x squared plus 2x, you still get a positive number here. So actually both of these are valid answers. And angles can actually have a negative measure anyways. But that is it. Thank you.